Hello and welcome. Please do me a favor and fasten your seatbelt as we are pulling and analyzing real-time as well as historical data from Uniswap, the world's largest decentralized cryptocurrency exchange. We are doing that with Python. In specific, extracting transactional swap data, and we're also sending paginated queries. Important here, please watch the previous video on Uniswap to better follow along. I will link it below. And even more important, show the video some love. Alright, let's get started. These are the necessary libraries: request, pandas, datetime as well as time delta from datetime. And the first thing I'm going to do is to define a function which is taking a given pool address and a lookback period. And this function should provide me the prices for a given pool address and lookback period. So I'm just naming that fetch pool prices, and as said, this is taking a pool address as an argument and also a lookback period. We provide that in minutes, so 400 minutes, just a random number here, which is our lookback period. Within this function, I need an end timestamp, and for now, I'm just taking the logic that I want to have prices until now. So I define a timestamp here, UTC now. Why UTC? Uniswap servers are in the UTC time zone. I cannot take my time zone here as I'm in a different time zone than UTC. So how does that look like? Simply like that. So today, 11:16. This is until when I want to pull prices. Now from when I want to pull, that is my start timestamp. And that is simply my end timestamp, which is now, minus a time delta. And I'm going to provide the argument minutes, which you're passing when calling this function. So how does that look like? So that is my end timestamp. Let's say we go 15 minutes back. Then it simply looks like this. So 11:01. Alright, so it's just subtracting minutes from the current timestamp. That is our time horizon. Now I can define my GraphQL query. As said in the beginning, important, watch the previous video. I'm going more into detail how you define a GraphQL query. It's not very complicated, it's no magic, but you have to get used to the syntax. It's quite similar to SQL as mentioned in the previous video. But anyhow, let's define the query for now. So I'm going to access swaps. Why swaps? Logic behind that. I'm screening a pool and I want to have every single swap transaction. So what is a swap transaction? A swap transaction is simply that any user, bot, or whosoever is swapping a current cryptocurrency into the other one, right? So he's selling ETH and is buying BTC. He's buying BTC and is selling ETH and so on. So I'm just extracting all those swap transactions in the pool. And with that, I know exactly what the current price is as he's doing that for a certain price. So swaps, and then where? First of all, very important, I only want to have the swaps within my pool. So I define my pool as a placeholder. And obviously this placeholder is going to be the pool address we provide for that function. So I'm in my pool now, have all swaps. And now I need to define the time period for when I want to have my swap data. So I provide timestamp GTE, greater than or equal to, abbreviation, and take another placeholder here. And this placeholder, obviously, is going to be the start timestamp because I want to have all swaps which are greater than or equal to my start timestamp. Same story for timestamp lesser than or equal to, LTE, abbreviated placeholder, and that placeholder is going to be my end timestamp. And with that, I've defined my time period in that query. All right, so these are currently placeholders. We will fill them in some seconds. Next, I want to order by the timestamp, and my order direction is ascending. Then, as explained in the previous video, I'm just pulling certain columns here, and the only columns we really need for now is the timestamp value, amount 0 and amount 1, which is simply, typo here. Amount 0 is simply first coin, amount 1 is second coin. That's the GraphQL query. Now we, or I, or whosoever need to provide the placeholders here. So first placeholder, obviously, this one is the pool address. So just the address which is going to be passed to that function. Then second placeholder greater than or equal to is going to be the start timestamp. And important here, GraphQL or Uniswap or the Uniswap API in general doesn't understand timestamps as they are defined in pandas. You need to provide them in Unix timestamp format, and there's a very convenient function call here, which is timestamp, and then you're getting it in Unix format. So provide the timestamp as a Unix timestamp here. Side note here, you can also just directly work with Unix timestamp format here from the beginning on. I'm not doing that here for no real reason. You can also do that, just add some more logic or complexity here, but it's also not that much of a hassle to do that. You can also do that right here. So, and timestamp, same logic. Use the Unix timestamp here, and then you're good to go. So you have defined a GraphQL query accessing the swaps for a given pool address, a given starting and ending timestamp here, and you order that by the timestamp and only pull the timestamp amount 0 and amount 1 column here. All right, that's it for the query. Now we need to send the query to the Graph API. So URL is, and I'm going to copy paste that here to save you some time. So this is simply the Uniswap v3 API, and then we are just going to use requests and post our query. So JSON query is query, and then store the response in a data variable here. So response JSON, doing a JSON transformation here, same story as in the previous video. And then we are extracting the swap data from that JSON object. You can just use data get data. You can also index. I'm usually indexing here, but I found this one quite useful here using the gets. Doing that a lot in the most recent time. You can also just index as I do normally in the previous videos. So df is data frame of that swap data, and then I'm going to return that data frame so you see what is actually going on here. So let's save some space here. So that is the full function here. Now we have defined that function. Now let's call it. So fetch pool prices. We need a pool address here, and as said, I'm taking a Bitcoin ETH address. As said in the previous video, very important, you have to provide it in lowercase letters, otherwise it wouldn't work. So you see some capital letters here, wouldn't work if you provide it like this, so just use a lower string method here. So provide the pool address, and then we're just keeping it as the current lookback of 400 minutes here. So fetch pool prices. So how does it look like? We get this here, right? So how can you read that? You have a timestamp which currently doesn't make much sense to you or me or anybody else except the computer, because that is Unix timestamp format. I'm going to transform that to a human readable timestamp in some seconds. but you see row-wise data, you have amount 0 and amount 1. That is the coin 1 and coin 2. So this transaction here, or this swap, is simply he sold amount 1 and he bought amount 0. Here it's vice versa. He sold amount 0 and bought amount 1. So this is how you read it. So let's do some data transformations here, so to make it even more lucid or more clear here. So first of all, the timestamp column, as said, has to be in human readable form. So pandas to datetime, df timestamp, and then the unit as s. So you have a human readable timestamp, and then we want to have the actual price. And the logic behind that price is that the price is simply the amount 1 divided by the amount 0. So, I mean, that's simple logic, right? So you sell and you buy something, and you will sell something for a certain amount, and you buy something for a certain amount. If you divide it, you will get the price. So I'm going to call that price, and to make it even more clear here, calling that ETH BTC. And that is simply this column, and then division. So df amount 1, and let's do a type transformation just in case here. So doing a float typecast here, divided by amount 0. And as you have swap transactions here, and you have either here or here another sign, so a negative sign, so because he sold, or the bot or the person or whosoever sold or bought, we're just taking the absolute values here to get the price. So taking the absolute here and divide it by the absolute here to avoid any wrong transformations here. So let's execute that, and then it will become very clear what you will see here. So you have a timestamp, so 250. You see that the price here is 18.37. And then you see how the price was developing over the last 400 minutes here. All right. Now, what you might already see here is a slight problem, and that is you only get 100 rows. Why is that? Let's provide another or a longer time period. So let's say 1000 minutes, but you still only get 100 rows. Why is that? Or what's the issue here? If you've worked with APIs before, you will already know it's the problem of pagination. So a single query only provides you a limited number of rows. So it doesn't matter how many minutes you go back, you always only will get the first 100 rows here. So it's limited. So let's tackle that. Therefore, I'm going to copy paste the function from above and do the necessary amendments to that function. So let's copy paste that and call that fetch pool prices paggy for pagination. Now in general, what does this function have to do? Instead of just one query, we are sending queries until we are not getting any data from the API anymore. We need to keep track of what is being provided from the API with an identifier, which is going to be the ID. So what we're going to do is we are just sending out an infinite loop and pull data from the API over and over again, while making sure we are not pulling anything duplicates, by keeping track of the records with the ID. that is basically what I'm going to do with that function here. So first of all, let's do some amendments here. So let's pull the URL above here and then get rid of that below here. And now let's store all data we're getting from the API in a list. So I'm just calling that all swaps, as this is containing all swap transactions. And this is simply an empty list. And this is going to be populated with the infinite loop. So here we are storing every iteration of queries we are sending to the API. Then we need the identifier to be able to keep track of the records we're actually pulling from the API. And initially, I'm just keeping that empty. So this is just an empty string here. After the first iteration, this will have a value, so it doesn't pull those rows again. Now we're getting to the interesting part, and that is the infinite loop. So while true, so just to trigger an infinite loop, and then everything here has to be indented. And now we need to do some amendments here. Every single iteration, we want to pull the first 100 entries. So we have to add here swaps and then first 100. Where stays the same, so we provide which pool we actually want to pull data for. Timestamp also same story. And then we need to add another parameter, and that is the ID greater than. And that will be also a placeholder for now. And actually use a colon here and not an equal to, as I did for the other parameters. And this one is going to be always the last ID from a query we send. So in each iteration, we are sending a query, and the first query, we don't have any ID. So we are just pulling the first 100 rows. But then on the next iteration, so the second iteration, we want to have the next 100 entries. So we are just providing the last ID from the very first iteration. And in the second query, my records should have an ID greater than this last ID. So with that, I'm just going through all the records which I'm interested in. So ID greater than the provided ID here. So we will add that to our parameters in some seconds. Now we have to order by ID, otherwise we cannot use the ID identifier for the records here. Now we also need to pull the ID column here, so we're just adding that in the column section here. And that's basically it. We just need to define the placeholder here as last ID. And with that, you have defined the query here. Now there have to be some amendments to that function still. And that is when you pull those swap data from the API, then it might be that you're not getting any more data in a specific iteration simply because you went through all the records, so there is no data anymore. And for that, we need to define a condition. So after we pulled the swap data and extracted the swap data from the response, if that doesn't contain anything, we want to break the loop because it just means there is no more data to pull. So we want to exit this loop. When there is no data, we don't want to pull data anymore. Now, in every single iteration, we want to extend this list by the pulled records. So we simply take all swaps, extend, and then swaps actually, and then extend that by the pulled swap data from the API. So what is happening? First iteration, it's pulling swap data, the first 100 records. Then it extends the all swaps list with that first query. and is storing the last ID of that query, which we will define now. So we are keeping track of the records and don't have duplicate entries. So in the first iteration, we have the ID, and the ID is simply the last ID value in this pulled swaps data. So last ID is swaps and then the very last row, and then simply the ID value. So now we have a last ID value, and this is being filled now in the next iteration. So we have last ID after the first iteration went through, and this now is being provided to the next API call in the second iteration, and now we have ID greater than this last ID, and now we're getting the next 100 rows. And then same story in the next iterations. We are pulling, and then we are always pulling greater than the last provided ID. Now, one more important amendment here. It might also be that you're going through the records and you're not getting 100 rows anymore. That means you're at the end of the pages. So it might be that the last page only contains 20 records or 50 or whatsoever. So we also need something like that. If the length of swaps is smaller 100, we know we pulled all data as we're not getting full entries anymore. So we can break the loop. Then we are creating a data frame of the all swaps, which is the populated list with that while, so with that infinite loop. And then same data manipulations and same price calculations. So if we execute that and call that function, fetch pool prices Peggy, I'm just taking the pool address from above, so Bitcoin ETH pool, and let's just go back 1.5k minutes, so a lot of time. You will see that you are getting a bigger data frame, 553 rows here, going back until the 22nd, so you have more rows than that. And if you even want to go further back, you can take, let's take 5k minutes here. You're getting every time horizon you might be interested in. So let me summarize how this function, so now you see 2.6k rows and so on. Let me summarize what this function is doing. Let's go through it once again because it's quite some code here. So this function is populating a list, keeping track of the ID value in the queries you provide, and then is just firing an API request on that data over and over again and avoids pulling the same records by the ID value. So by just extracting the last ID and then is only pulling data points which have a larger ID than that. And it is doing that until you're not getting anything anymore. So until your pull data is empty, or if your data is smaller than 100 records, you also know that you're on the last page. So the loop gets broken here. Yeah, and that's it. So, I mean, you can do a lot with that, right? You're getting all transactional swap data. You're getting the prices. So let's store that somewhere. dfx is this one. And then you can take a look at what's actually going on. So by plotting, for instance, the price development, yeah, that looks a bit off because the index is not defined. So you have to set the index to timestamp, of course. So set index timestamp. And then you see the price development of ETH versus Bitcoin in this pricing pool. Super interesting. So, I mean, that is just the pure basics, but you can make a lot out of that, right? So you can track prices on all pools. You can do some very interesting data analysis, even data science projects here. So, I mean, if you're interested in that, let me know. I found this topic very, very interesting. And yeah, that's it for this video. Thank you very much for watching, and I'm looking forward to seeing you in upcoming videos. Bye bye.